The flight path angle is this. Once you say as a person, you lay on here, you can see the angle, the direction of the velocity is up top your head. So say this is the center of the focus of the Earth. If you stand here, then of course your head is pointing to our direction. So from here you can feel the direction of the velocity is kind of flying over your head. That is the positive flight path angle. Okay. And then if we go down to here, then you can feel that angle will be kind of going into the surface. So that is negative. Okay, so we go to the different section. Then gradually, because right now we already built up the equations of the orbit and then also filling up a few the informations. So the remaining content of the chapter 1 is try to relate the conic sections, which means the geometry and the orbit. So here I'm going to prepare for those. And again, equation of the orbit is here, and also you have learned is the mechanical energy, and also we have related to, for example, minus mu divided by 2a. A is for the first time we know that A is certain parameters in geometry, shape of the orbit. So now we're going to do a little bit more about these things. And to prepare for this, and I need to kind of lay down a little bit more information here. So from the eccentricity vectors here, let me rewrite v of h minus mu over r. Okay, so here we take the r in the product with these equations. So this is eccentricity vectors. Then we simply take the r dot in the product of these vectors, and then we see. Okay, so therefore, on the right hand side, r dot v times h minus mu. And this one we can rearrange, and that is h dot r plus b. And because remember this is actually is h, so therefore this one is h squared minus mu over r. So therefore r dot e equal to h squared over mu minus r. And if you remember, this one actually is a defined parameter p. Okay, but that's not critical here, but kind of remind you. So here we have this one, then we can simply rewrite into this form. R equal to p minus E dot R. And I'm going to, based upon this relation, and to build up a bit more geometrical information about the orbit. R is the radial distance from focus, from the major focus to the location of the celestial objects. P is the, we call that defined as the parameters, and P is related to the angular momentums. And E is the eccentricity vectors. R is the radial displacement. So here, with those things, then we can do something. me call this equation 1. A few options, 3 options. Because this is a vectors equation, this is a scalar quantity. Scalar quantity involves the inner product of the 2 vectors. So that means here this should be universal regardless of the coordinate system we use. Okay, and here I want to look into 3 options of placing the origin of the coordinates into somewhere in the orbit. We see what happens to this equation, and then we're going to have those foundations prepared for the remaining lectures. So the 3 options of placing the origins of a Cartesian coordinate systems. Okay, so here we use the Cartesian coordinate systems. The first option is this, the origin locates at the main focus. Okay, and so say this is the part of the orbit, and this is the main focus. So here this is the Cartesian coordinate systems xy. So here we place the origin there. Then the second options, okay, so here I wish is I align the drawing. So here the orbit will be something like this, and so this is the focus. It's not our point, the concern anymore. The center is this is the focus. This is the center. So you can see here in my drawing, I align my orbit in the same location, align my focus at the same location. So here, this is the coordinate systems. Okay, so this is center here. And so the center, we give the distance from the focus, C, okay? And to distinguish the coordinate system, let me call this called the X prime, this called the Y prime. Okay, the third one, the origin. So here, this is the orbit, and this is the perigee. This is the focus. So here is the coordinate systems here, and so here we locate the origin and the perigee, or we call the pericenter. Again, that's a different Cartesian coordinate system. Let me call the X prime, Y double prime. So here we have 3 coordinate systems, and we see. So now for the first one, and say here we have a point here. So that is R, okay? And let me do the bigger one. So the point here, they are the same here, okay? So here, those are the points we considered. So for this one, so say here R has the coordinate x and y, and then this is the vectors E. The vector E is also in that direction. Okay, so here the vector E is also in that direction. The vector E is also pointing in that direction, so they are the same. Okay, the vector E is the vectors pointing to connecting the focus to the perigee. So basically, they align to the horizontal axis. So now we can use equation 1 to see what happens. So here for E dot R, simply is the E dot R has the coordinate x and y, and E is aligned into the x direction. So basically, this one simply is EX. Let me do this one here. E equal to E and 0 dot xy. Right? So basically that is EX. Okay, so therefore equation 1 becomes R equal to P minus EX. So let me call this equation 2. For the second options, we simply is to do the real body translation of the origin to here. And so from here you compare the coordinates between the x and x prime. What we have is x prime simply equal to how much? When x corresponding to 0 is x prime corresponding to c. So that is x minus c. When x has coordinate equal to c corresponding, excuse me, let me repeat. When x prime has coordinate equal to c, so that should be x plus c. Right? If compared to this one, right now, let me extend it here. So this location is the origin of this one, right? So when x equal to 0, corresponding to this point is the where the x prime measure is by c. So here we fit into this kind of translation rule. So plug into here, then we have, so therefore, equation 2, or equation 2 becomes is this R equal to P minus E, and then we replace x equal to by x prime minus c. So that one equal to P minus EX prime plus EC. Here I'd like to give a head up, and although we haven't been there yet, but C can be described as the quantity of the parameters, and actually that equal to EA. E is the eccentricity, A is the distance here. From the center to within the semi-major A. Okay, so here we can plug in C to that one. So therefore that one equal to P minus E x prime plus E square A. Okay, so let me rearrange. So that is